Hello, everyone. My name is Garrett, and I'm a math tutor at the DLASC. And today I want to talk about how to deal with resulting forces when it comes to some of these statics problems. So here, let's just look at here. We have a problem, and it's we have our XY graph. We have F1 and F2, and we're trying to find. It says the resultant is 750 newtons along the x-axis. Find f of 2. So this is a little bit of a different problem. Usually you're given three things and you want to find the resultant. But here we're given the resultant and we're trying to find one of the component or one of the vectors, right? We're trying to find vector 2 here. And so the way you would do this is, you would start it just like any resultant problem, right? You would start it by trying to find your F1s and your F2s and all that thing. So the first thing we'll do is we'll break these three vectors up into the x direction. So what we'll do is we'll say, let's erase that. We'll say, this is our x direction. All right. And basically what we're going to try to do is we're going to try to sum up our forces in the x direction. Or let's not say, we're going to sum up our f of x's. And how we'll do that. So it looks like, let's do force number one. So force number one, if we look at it, it's this vector and it has 325 newtons, but it has this little triangle on it, this 5, 12, and 13. And basically what that's saying is that is it's basically giving us the angle here. Because think about it, this triangle is going to be proportional to our big vectors, right? And so what we can do is we can say F1's angle, right, is going to be proportional. So the way we do that is you got to think F of cosine theta. That because we're looking for our x direction, that is what we try to use to find for the x direction. We have some information about this. We know about this little triangle up here that cosine of theta is equal to, what is cosine theta of this triangle? It's going to be 5 over 13 because it's adjacent over hypotenuse. You can think of this little thing as the angle here, right? And so it's going to be 5 over 13. And so that's what we'll put. So cosine theta is 5 over 13. And so given that, we can just write F1 as equal to our F, which in this case is 325 newtons, right, given by up there. So we can say 325 times cosine theta, which is 5/13. So we can say 5/13. And then obviously when you evaluate this, it's going to be 300 newtons. All right. So that's F1. F2, we don't know what it is, right? It's just some F2 times cosine of theta. We don't know what theta is either, so we're just going to put it like that. That's all we have. And then F3, if we take a look at F3 here, F3 is pointing downwards and with a volume of 600 newtons. So it's down with 600 newtons. So that's our F. And then it's going to be cosine. And I forgot to put here, this is 45 degrees. This should be in our problem. Okay. So it's going to be cosine of 45. And that's going to be in the positive direction because we're thinking about it in terms of x. It's not going to be in the negative direction. So when we evaluate that, that's going to come out to be 424.3 newtons. And so what we're given is our resultant here, FR, is equal to, is equal to 300 plus F2 cosine theta plus 424.3. That is our resultant for the x direction. And we don't know what it is yet. So we're just going to keep it like that. I'm sorry. This shouldn't be 300 newtons. I thought I saw something wrong. But up here, when you evaluate it, 325 times 5 divided by 13 is actually 125. I was confused. And this also should be 125, right? But in any case, that's what we have. That's our f of r. And so we don't know what f2 cosine theta is, so we're just going to have to, let's just do the y direction first. Let's get our information. So in the y direction, what we're going to have is the sum of y's, right? F of y. And what that looks like is our f1 of y equals 325, because that's our that is the f1's newtons. But now you got to look back at our problem here. We're taking the sine of our f1, so it's going to be 12 over 13 here. So we go back here. Let's put it back to 12 over 13. And when we evaluate this, this is going to be 300 newtons. I picked the wrong one at the first time. So, and same thing with f2. We don't know what it is. So when we evaluate that, it's just going to be f2 sine of theta. And then f of 3y is going to be, now this, you got to think about it, it's going to be in the negative direction, right? Because y, the y component is going downward here. So f of 3 is going to be negative because of the direction in the y it's going in. It's going to be negative 600 times sine of 45. And that is going to equal, when you evaluate it, negative 424.3. All right, and we're almost done. Now we just need our f of r of y. And that is all that's going to be is it's going to be this here, right, added together. Well, actually, and then plus that too, right? Don't forget that. So it's going to be 300 newtons plus f2 sine of theta minus 424.3. All right, so we have our FRs here. And what does that do? Now, we know that this, but we don't know what our F2 of is. So you got to think about it. We're given our resultant force, okay? So you got to think, here's our x direction. So we have this equation 125, right, given by this, plus F2 cosine of theta plus 424.3 equals, and in the question, it gives us our newtons for the resultant. It says the resultant is 750 newtons acting along the x-axis. Okay, so that's going to be 750 because we're thinking about this is f of x, right? And then our f of y, and this is summed together. Our f of y, this is our second equation, is given by this here. So we'll do 300 plus f2 sine of theta plus or minus 424.3. Now, don't go ahead and put 750 here because this, if you think about it, our resultant force is something like this. This is our resultant force. It's acting upon, this is our f of r. It's acting upon the x-axis. So it has a 750 newtons acting upon that. That's what's given in our problem. The thing is there is no y component to this. It's not acting in any way to the y component. It's acting directly towards the x. All that 750 newtons is going towards the x-axis, and none of it is going up or down. So when we think about the y over here, we are just going to put a big fat 0 because there is no, y component into this resultant force. It's given in the answer in the question, right? It's only along the x-axis. And so now what we have is we have two equations and two unknowns, right? We have our F2 sine of theta and our F2 cosine of theta. So it's basically theta and F2. Those are our two equations, two unknowns. And so we can solve this using a systems of equations. So first things first, we're going to try to isolate F2 from the first equation. So we'll come around here and say that F2 equals, and when we subtract both sides and divide it all by from 750, we're going to end up getting 200.7, and then this cosine theta divides out over here, so it's going to be cosine of theta. So now we have our things when it comes to F2. And so what we can do now is I'm going to go ahead and make this blue here. We're going to plug this and this into this equation. And so what that ends up being is we're going to get 300 plus well, hold up. Before we do all that, what we're doing is, it's going to be 300. Sorry, it's not going to be 300. We're taking, let's back up here. What we're doing is let's isolate F2 and F2 cosine theta and F2 sine theta. So what we're given is we're given F2 sine of theta is equal to 200.7. F2 sine of theta, or cosine of theta, is equal to 124.3. And these are flipped. This is given from this here. So then we can do this. When we isolate that, it goes here. And now, given this, we know what this is. It's 124.3. So now what we're given is you have 200.7 over cosine theta. That is F2, right? We're doing this here, times sine of theta. Okay? I hope you followed me there. It took me a second to remember what's all happening, but we're trying to use F2 sine of theta. We're trying to, we isolated F2 so we can plug this isolation here into this equation. And when we pop out this, and this is going to equal 124.3, because when we did all the math here, we got this equation. So it was a little tricky. I always get a little mixed up with the systems of equations because there's a lot of things at play, and so you got to make sure that you do your bookkeeping, right, as they call it. So it's very important. So it's good that we went over a problem like this. So anyway, in any case, this is what we are given. So now what we have is we have theta, just an equation that involves theta. And so what we can do is we can say sine of theta over cosine of theta is equal, when we divide the 200, or divide 200 by both sides, that would cancel out, and then this divided by 2, or you know what, we'll just write it instead of me trying to talk about it. Divided by 200.7. So then this converts to tangent theta. This spits out this number, 0.619. And then when we do the inverse tangent of both sides, we get tangent equals 31.77. So we have our theta for our f of 2. So when we go back up to our picture here, yep, this is going to be our 31.77. Great. So we have our theta. So now what we can do is we can take our theta and plug it back into that equation there, finally. So we can find our f of 2 now. So when we do that, we get our f of 2. F of 2 equals 200.7 over cosine of 31.77 degrees. And when we do that, this spits out, when you put that into your calculator, f of 2, our magnitude of it, is equal to 236.1 newtons. That is our second answer. So when we go back to our original over here, we can say that this is 236.1 newtons. So we have found f of 2. And if I were to say, put this in final, well, we've already circled our answer. So these are our answers. We found f of 2. And that would be our final answer. The big thing here is it looks a little messy, but the idea is when you're seeing a problem like this, okay, you want to break the components down in all the vectors resultants down into components. And so you take the components of 1, 2, and 3, 1, 2, and 3. For your x side, you do it for the y side also, 1, 2, and 3. And then you're just adding the forces together. Okay, and that gives you your resultant force. And then from there, you know, at that point, if you're not solving where you already are given the resultant, you can just plug in that as your answer. That's your resultant. But in this case, if we built ourselves a system of equations because we couldn't find f of 2, and so there is a little bit of this kind of system of equations work with certain problems, especially when you go on further. So it's a good little practice example to practice. You know, a lot of the times you want to try to get it into where you have 2 equations, 2 unknowns, 3 equations, 3 unknowns, and it's almost like a puzzle at that point where you're trying to fit everything together. But yeah, my name is Garrett, and that is resulting forces here, are finding the resultants of forces. And so happy studying, y'all.